Hey everybody, it's Bruce. I've got the dog on the floor. This is Groxio, and we're here to talk a little bit of Elixir. Today, this is a bonus chapter, and we're going to be talking about a common resume problem. The idea is that you have a string that looks something like this. Maybe you have angle bracket open, and then a square bracket open, and a parentheses open, parentheses closed, and then curly braces open, square bracket open, square bracket closed. Anyway, something like this. And the question is this a balanced set of parentheses? That is, if you open parentheses, is the very next one the closing of that parentheses? Basically, would this be valid code if you were to write and if all these types of parentheses were supported? So we're going to write that. And basically, the way that I found this problem is that this is a common resume problem. And we're going to write, a quick and dirty version of it just to kind of play with a couple of different Elixir concepts. So anyway, let's start out by looking at a couple of pieces of Elixir. So if we're going to start with input that looks like this, so let's say brackets, and maybe I have maybe just 3 different types of brackets, like that. So maybe I have these 3 different types of brackets like that. And maybe then I want to start to pick them off and process them one at a time. So I think my strategy is going to be, I'm going to open them one at a time, and I'm going to push them onto a stack if they're open ones, and I'm going to pull them off of a stack if they're closed ones. And basically what I'm going to put on the stack is the matching close for the type that we're opening. So that means I need to be dealing with these like a list. And if I do an I, which is basically it inspects the last statement in IEX, I can see what data type this is. This is a bit string or a string or a binary. So these are the modules that have the functions that I can work on. And one of the things that you don't see is list. I see this list chars here and string chars. But what I'd really like to do is convert this to something else. So let's do that. So let's string and let's convert it. And I'm going to press tab, and that's basically going to give me a list of all the functions that are available to me. Well, I know that all of my conversions look like this. They're in 2. So I'm going to say 2, and I'm going to press tab. And so that'll shorten my list a little bit, and I can find this 2 char list. So I'm going to do that. And the command that I want to check on is 1. So you can see this line right here. It's the very first line number in IEX, and I can grab that with V1. So I'm going to say string to char list V1. Yeah, and so this gives me this char list, and so if I do an inspection on that, that looks a little bit better. So this data type is a list, and let's see what one of the elements of that list is. So let's say my list is equal to, or let's say brackets. That's more descriptive. So let's get the head of brackets. And that's a 91. Interesting. So that's a number. So essentially this is a code point or the ASCII representation of this thing. So basically if I want to get that, I could say question mark open bracket, and that's a 91, or press question mark close brackets, and that's a 93. So let's put that in our back pocket to play with a little bit. And so I think we have enough to start playing around. Well, no, let's look at one more thing. So let's take brackets and let's break that up into the head and the tail. So this is called a pattern match, and we're actually going to use this. And so the head, that should be a 91, or the first one. And the tail should be everything else. So this is how we'll pick off the first element, and how we'll actually compare to the first element in later in our functions when we're ready to write them. So I'm going to break out of here, and I'm going to say mix new brackets. So one of the things that you want to do if you're solving a resume type problem, or if you're solving a problem as a code interview or something like that, you want to write pretty clean and simple code. It doesn't always have to be the most expensive, the most performant, but it should be a relatively clean implementation and should have short, clear functions that are easy to understand. So that's how we're going to write this code. And so let's open this up in my editor. I'm using Atom. You can use what you want. But we have brackets here. I'm going to go ahead and take since we're working on an interview question, it'd be nice to hold on to this documentation. So so the module doc is determine whether brackets are balanced. And then see link and maybe you could have a link here for details, or maybe you could copy in the see problem description for details or something. But anyway, just this here, I'm telling the company that I'm interviewing with that I know how the module documentation works. And so this is the module documentation, and each functional documentation is going to be below. And let's say that we have one called run, and this is going to take a string. So determine, so outputs yes if the are balanced, like that. Okay, so and the way that we're going to process this, we want super clean code here. So we're going to say string, and then what do we want to do? So let's say we're going to say string to char list, right? Because we're going to run our balanced program on the char list, and then we want to take that and we're going to pipe that into balance, and this has a question mark, BA. There, that's better. So balance, so that has a question mark, so that's going to return a true or false. And then I'm going to say to, so, and then out. Let's say output, let's say render or print. Okay, so let's write that print function. And we'll say yes, and if it's false, otherwise we're going to say no. So this is actually superior because we're going to take any other string. We'll be able to handle bad inputs that way. If we don't want to raise an error, you could raise an error, I guess. And then we need to write this function right here. So let's start with the def balanced, and then I'm going to take a char list, and I'm going to run a helper function. And it's going to have a different arity. So this will be a balance too. So I'm going to make this, this API, I think I'll keep public. And this one, balance. And this is going to take the chars and the look or search, or let's say the first bracket, right? Or let's say the stack. That's probably a better word, bracket stack. But let's say if this is, and I want to document these, but if this is empty and my bracket stack is empty, and I'm basically putting the underscore, I'm putting underscore chars and then underscore bracket stack to document what I've done. So if there's nothing left, an empty string is going to be balanced. So this is going to return true. And so now I need to say, now we need to start to think about the problem a little bit more. So I want to say these are the type of brackets that I support. So I'm going to support these, and these, and these. So I'm going to surround that like that. And I'm going to put a percent in front of that. And I'm going to split my cursor. And I'm going to say question mark that. So we're building a map here with a question mark the other one. Yeah, okay. So let's see what we have. So so basically we have all the mates of these. And then I'm going to need, so the opens, and that's going to be the keys for brackets. And then the closes is going to be the map.values for the brackets. And this will let me, so since these are computed before I actually compile the rest of the file, I can use these in guards, and that's going to be pretty useful for me. Okay, so let's think about what's going to happen if I run into a function and it's one of the opens. What do we want to do? Well, we probably want to add, so let's write out the conditions. So let's def p balance. And I want to say take the head and the characters, and I want to take the stack. And this is when the head is in the opens. Okay, so when this is an open, basically, I want to put this on the stack of the ones where we're going to look for. We're going to wait and see if we can counter it again as things are closed back up. So it's going to look like this. So we're going to ask, is the rest balanced? Is the rest of this string balanced? Are the characters balanced? When there's one more head on the stack, right? We don't actually want the head on the stack, do we? So this is the opening character. We want to basically look for something that is, we want to look for the mate. So let's write mate of a, the mate of a character is the brackets. The brackets, right? So if we get an open bracket, we want to push a closed bracket onto the stack, right? So that's how we're reading this. So what's going to happen is every time that we get another character, we're going to add it to the stack and then go ahead and check the rest of the list. And eventually we hope to find the closing bracket, right? So what happens? So if we have a head and the rest of the characters, and so what happens if we find the matching one? So if it's not in the opens, then we're going to assume the character is going to be one of the closing characters, right? So if the only closing character that's going to make me balanced is the one I added to the stack, right? So, and this is going to be the stack. And all I have to do is check to see if the rest is balanced. Oh, and I didn't finish this one up here, did I? So what is that? That is the mate. The mate of the head attached to the rest of the stack, right? So all we've done is if we open it, we move it over to here and we hope to find it later. And that means that the very first one that we're looking for is the very last one that was added. And so it's nice the way that this works out because these are going to be built and destroyed head first. And that's exactly the way I want to use a list in Elixir. So basically, if these heads are the same, then the pattern match is going to work. And all I have to do is ask, is the rest balanced? Right? And so now I could say, hey, if this is all empty, everything is balanced. If I run across an open one, I'm going to push it on the stack and then I'm going to go ahead and cruise right on down. If the heads are the same, I'm going to just eliminate those and check the rest of it. And then I don't think that there's any other good conditions. I think everything else, this is the chars, and this is the stack. Whatever happens now, I think that this thing is not balanced. So I think that we're kind of fortunate in this way that should be enough for us. So we might have to do a little debugging. And if we do, what we'll do is pipe these. Well, maybe we'll do this anyway. We'll pipe these to io.inspect. And we'll talk about that in a second. Okay, so all we're doing here is this is chars 1, and this we'll call this chars 2, and this we'll call stack 2, and we'll inspect the oh, you know what? These are wrong, aren't they? Okay, all we need to do is label those, right? It's because we're getting the argument from the other side. So we're going to label this chars 1 and chars 2. We're going to label this stack 1 and stack 2, right? So basically, what we're going to see is all of these as they come on through. But I think we'll be able to see if this works. Okay, and so we're getting a warning and an error. So we have a balance 2. Let's see. Oh, I see. I bet one of these is a def P or something. So balance to balance 1, 2, balance 1, 2. What is this telling us? Balance 2 is defined as def P. Oh yeah, and so it is, right? There's my def P right there. So I think that this should be a public API, right? So this is balance 1, and this is balanced 2. And so these are all defined together. These should probably be privates. They're helpers. Yeah, so I'm going to call all those privates. So let's recompile. So start IEX again. Okay, so we're still looking for, so we have an undefined BALANC ACED, misspelling. Okay, let's see if we can find this. So I'm dyslexic, so these things are my kryptonite, right? Oh, right there. BALANCED, right there. Okay, so that's beautiful. Undefined function balance 0, so that is on 21. Okay, yeah, so we didn't check. So what do we need to define here? So this is, we're going to take the char list, and our stack doesn't have anything on it. So that's correct. Great. So closes was set but never used. We didn't need that, did we? That's okay, so we're happy to go ahead and delete that. So we use this to compute, to say, hey, these are the open, close, open, close, open, close, and open, close. They're going to determine our mates, and they're going to determine the opens. Because we do look for the opens right here. This is in fact the case for the closes, but we don't have to look for it because we know we only put closes on this list, and we only peel them off. So recompile. Okay, so we've got no warnings. That means I didn't save, and so we recompile and we're good. And so let's try to run. Let's say brackets.run. Let's run an empty string. Okay, so that's balanced. And so let's see if this works. Okay, so what's happened is that the first run through, so chars looks like this, and the stack one looks like this, and then there's nothing in the second chars, and there's nothing in the second chars on the second pass through. So this is working exactly like we want to. So this is when we put them on in the first place, and this is when we pick them back off. That's fantastic. So let's see if this runs. Yes, so that's balanced because we start with this is the tail, and this close is going to match that one. And this, okay, this is working beautifully. Yep, this is doing exactly what we want. So now we can try to run something that's not balanced. Let's throw something else in there. That's great. And let's throw some angle brackets in there and some parentheses in the middle. And we are working beautifully well. So that's balanced as well. So I think that we're about to call victory. Almost though. So one of the things that we want to do is clean up this output. So let's take out these IO and specs. Okay, so we're still running there. So the only other thing that we need to do is run a test, is write a test. And so the bracket test, this isn't going to run like that. It's a little bit sloppy to leave it like it is. So a lot of people will fail you on a code test if you don't write tests. And some are looking for you to actually write the test first. So I didn't do that because I wanted to walk through the zen of the problem with you and talk through what that looks like. But let's go ahead and say, so dtext, so an empty string is not balanced. And so we're going to basically define a couple of characteristics. So I'm going to say so what do we call this? Do we call this run? So I'm going to go ahead and not test this one because this has a print condition in it. I'm going to test from this API. And if I were in a code interview, I might describe why I made that decision up here. I think that I won't, though. An empty string is balanced, isn't it? That's okay. So let's run tests here. Assert balanced an empty string. Oh no, that needs to be, this is a char list, right? So let's see. Yeah. And so now I could say, so a list with remaining, right? So if I have something like this, and this will be refute, and then I'll also build a string that looks like this. Like that, and maybe have a couple of them in there. Okay, and then probably I would do so I'd probably do something like this, and then have some opens, and have some opens, and opens like this, and then have an open and close like that. And this is an assert. And let's just, and then you could basically run a few like this. This is probably a pretty good scenario where you could have property-based tests, but we're not going to do that. Like that. Okay, and then so if I have a few extra opens in there, so let's do an open parenthesis here, and let's do an open bracket there, and so those should be refutes, shouldn't they? Okay, and so if I'm grading this coding test, there's a couple of things that I like about it, and I'll pick on some things also. One of the things that that isn't perfect is that I have stripped out my doc test. My doc tests, so some might complain about that. I probably wouldn't. In addition, so another thing that I probably wouldn't like about this is some people don't like this style of program. And so if you have a strong opinion on code like this, make sure you bring out why you hold the opinions that you do. So I like strong, I like a very narrow margin, and I'm willing to go through some pretty extraordinary lengths to do that. And also, I believe that short functions allow me to label my concepts. So I'm able to defend the style of code that I write, but I also can be clear that I can adapt to your code style and your code standards if you need me to. So, for example, some teams would like to see this code written in this way. Def print bool do, right? And then if O dot put s. Yes. That's funny. My code didn't even work. Because we never output anything, right? So some people like code written in this way, and this could also be with the cond. And then I could say bool or case. No, this is probably best as an if. I like that better. Could have written it as a true, but I think that this is better. Okay, so I don't like those things. Now the things that I do like about this program, well, after we tidy up this and actually meet our specification, right? So this needs to be io.putS, yes and no. The things I do like about this code are, first, it has a very tiny left-hand margin. I think that the greater the indentations on the left-hand side, the worse off you are. The second, I think that this has short but descriptive variable names. I think that allows us to define concepts well. The third thing is that I love the way that that we basically build on a single level of abstraction. We take the string, we convert it to a list to see if it's balanced, and then we print the result. And so this is really marvelous Elixir to basically shape our code such that we're telling a story in the pipe. I really love code that's shaped this way. The other thing is that once we get to our tests, basically every single test that we have in here has a single theme, and I like that. So the theme of this is that we're testing an empty string, so that's a boundary conditions. People will like that. We're testing another boundary condition that there are extra things left over. And if you look at the shape of our code, we're basically picking up the case that we've fallen through, where this is empty, but this is not empty, right? And then the other cases are failing in different ways along our various clauses. So anyway, this is a great Elixir, a pretty instructive Elixir problem, because it talks about pattern matching, recursion, lists, strings, module attributes. There's a whole lot to like about this little example. I really had fun writing it, and I hope you do too. So let us know in the comments below. Give us a like or a follow if you like it. Let us know in the comments below if you have other implementations of this problem that you like. Until later, this is Bruce at Groxio, and I'll see you.